How you doing, Michelle?
Oh, okay. Just like stuck in the hallway here. Our bathroom is being demolished and redone.
Oh,
There was a leak.
oh, well, sorry to hear that. I hope you are able to cope with all the renovation going on, huh?
Well, at least, it's going to be new.
Yeah, that's nice. That's the nice part.
Yeah.
Yeah, I'm getting ready to put solar in my house tomorrow. They're coming to take a look at my roof. So hopefully things go smoothly and then I'll be on solar soon. Well, 90 days, I said at least. So the end of the year. Hey, Kevin. How
Nice.
are you? Yeah, it's just, worry about California and not having enough power. And since we have a lot of sun, it'll be a good option to just, I use mostly solar lights outside, but just the air conditioning and everything is costly. So it'll be good.
Oh, yeah.
Yeah, I have a pool, so we run the pool all day. Otherwise, it goes bad. And yeah, I don't want to replace all of that water because we don't have enough water here in the state even. So, okay, it's 5 o'clock and it's time to do Numpy. um, so I posted your stuff, I think yesterday. Let me share screen. And you will find the notes on Canvas. And then let me also open the assignment. And also you will need to have the assignment ready. We're gonna do quite a bit of programming. So we are gonna start with Numpy, and today we're gonna do Numpy, and then I wanna focus on Panda in the lab because Numpy is very close to what we've been doing in other classes, and we talked about how to work with lists before when we did the review, so it's going to be really close to what we've been working on. So the chapter talks about how you can really operate the array and make things efficient. And using library like this, you're going to process data faster. And as you know, many of the Python library is written in C, especially NumPy and Panda. And so we want to take a look at how we can access data and or append data or store data effectively. So it starts with going into NumPy, and this is used quite a bit in the area of data analysis, data visualization, if you want to look at scientific computing, if you want to implement algorithm with complex formula, NumPy is your friend. So with that said, here is the information about NumPy. And we are going to do fast array operations in this chapter. And NumPy is part of Anaconda distribution. So if you ever use Conda, you probably are familiar with the introduction of NumPy. So there are two ways that you can install NumPy. The first is to use Conda because it's part of Anaconda distribution, and I put the link right here. You can also click this link and it's going to take you to how to install NumPy, and it's really straightforward. So, and this gives you the snippet on how you can use your virtual environment and install, which we've done already in our class. So you can enable your virtual environment using Conda. You can also enable your virtual environment like what we've done before using Python 3 command. And this is going to utilize Conda. So once you enable your virtual environment, you will have a working directory, you should put it into like a folder. So it's going to create my VNV. And with that, you can add the Conda Forge, and then you can install Numpy. That's one way. But what if I don't want to use Conda? What if I want to use Numpy with my idle? I can simply do a pip3. Remember that when you use pip, if you have Python 2, it will push it to the default installation. So you can simply do this, CMD, like open your Windows, and then you can do pip3 install Numpy like this. Okay. And it tells me that it's already been satisfied, but if you haven't installed before, it's going to pull and it's going to put, and notice that it puts it to the packages if you do pip. Now, if your pip is outdated, you just follow the command instruction that you can install it on C and then update your pip packages. So you can simply use pip3. And what this will do is going to link this library to my Python 3.9, which already exists, that I had installed using the Microsoft Store, right? And we talked about last time that some of you were having issues with Python not being linked to your system path. You have, if you use the new Windows 10 because of the update, they want you to install it through the Microsoft Store. So you have to, uninstall Python and then install the new version using the Microsoft Store. And that's going to be under a lib, site packages, and I would have that here. Now, does that mean that when you're using an IDE, will it work? No. So, so if with idle, the default IDE for Python, that works. But what if I use Tawny, or what if I use Visual Studio Code, right? So I use Tawny quite a bit because it's easy. Then what I have here is I want to go ahead and click Tools. Okay, you can manage plugins like what we've seen before. And here you just simply search for Numpy. Okay. And if you haven't installed it, it's going to allow you to install. Notice that it's the same version. It's going to put it into the packages. So if you can do it either way. You can do it through the IDE, right? You can do it, but if your IDE is not the default IDE for your Python packages, then you want to go in here and check, okay? And then if you want to install other packages like pandas, you just look, and I've done both, okay? So a way that you can do it is to make sure, and on Visual Studio, I believe it's under, also under tools, and then you can go through the options, and then you need to make sure that you download and link it there. Otherwise, it would not work, right? So to answer the first question, it asks you, how do you install Numpy? And, using conda and pip command in command line. You can use conda, and either way, I think you should use a virtual environment. So you need to enable your virtual environment, and you would use the conda command, and you simply use conda install Numpy, as is shown in notes, page 1. Okay, so here I just copy and paste it over so you can see that you can enable your you create your virtual environment, activate it, and then you need to do the conda forge, because that's where it's going to be able to pull the necessary elements for Numpy. The second approach is you would be able to use pip command, and using pip, you just do a pip3 install Numpy, and pip3 just make sure that we are for Python 3. Okay. Any question? So basically, the first question kind of stage what we're going to be doing. So before you can start programming the rest of the exercises, you need to install Numpy. Okay. And either way, whichever way you feel more comfortable, you can use that. I just specifically use Tawny, and I had pushed it through the IDE itself. But if you're still using idle, you need to make sure that you use pip3, or if you want to use Conda, you can use Conda to do that. Okay. Now on Linux and Windows, pretty close, right? For Mac, it's still going to install with pip. It's just you have to push, it's going to pull it from wheel. And so if you have doubts, all you have to do is to go into their documentation, which I provided the link, and then you can take a look. So here it talks about if you're beginning using Numpy, this is where you can look up the Visual Studio Code, and you can use Jupyter Lab. Jupyter Lab, you can install it, or you can run it straight from the browser. You can use Spider. There are many options, right? And then if you are an advanced user, they recommend that you can use Miniconda. So you have to install Miniconda, and with that, it will come Numpy. So here it talks about how you can set up Conda environments, which is what we saw in the first step. And then setting up the channel priority, which we also saw in the first step where you do the forge. And then for the Linux, you just do a pip install and then your Numpy packages, okay? So there are many ways to really install this package. You can refer to the documentation if you are using a certain system. Okay, any question?
I don't know if this question is for this class, but I had a problem last year where I had my Python idle, and then I also had Python and Anaconda.
Mhm.
And it seemed like when I tried to set an environmental variable, it would default to the Anaconda path instead of my idle path. And I didn't know if there was a way to fix that, because that was a problem every time.
Yeah, I think when you do Conda, it actually takes over. And that's the reason why I mainly don't use Conda. In that some of the packages don't necessarily build well in Conda. So I normally just do a pip instead of Conda unless I really have to use Conda for other things. But what I recommend is when instead of running Conda directly, you can also first you create your virtual environment and then install Conda to that virtual environment. That's what they show here. And that way you don't install Conda directly onto your computer and it's going to take over the default path. So you can try to put it into a virtual environment and only use it in the virtual environment instead of using it in the overall system. And that's what I recommend. So for us, we're only going to need Numpy and Pandas for this week. Unless, if you were taking other programming classes for data analysis, then they will likely ask you to put Miniconda or Conda on your system. So but you can put it on your virtual environment, okay? So with that, Michelle, the fix for that would probably be uninstall Anaconda and then put it on the virtual environment and then run it there. Okay, other questions?
Yeah, I guess because I use Anaconda in the GUI version, I just never use the Conda on just the console.
Yeah, you can do the GUI version. That's fine. Yeah, that's totally fine if you're comfortable with Conda. I know Dr. Lair, when he teaches Python, he likes using Conda. I'm not particular to a certain IDE or package to be able to program. I just think that, you know, as a programmer, you should have the flexibility to choose whatever that you like. And just like other packages, you can always remove the package and you can always, you know, install other software and work with those packages. So, okay. Especially in the Linux area, we can push it through command line quite easily. So the area that we're going to work with on NumPy is going to be your array, right? And this is going to be a way that we can create an array. So as you know that I said that this is written in C, so they refer to array instead of list. It's the same, right? It's a container that we are going to put in objects that's list-like, and we're able to modify it very similar to what you've done in string, like slice a string. We're able to iterate through and be able to access the index. So we are going to do some of that. But the benefit in this is that there are functions that were written for fast data access, fast operations. So that's the whole point in bringing in this packages, is to be able to utilize some of those methods that were incorporated in the actual library. So for the first part of this, it's going to show you how to create an array. Very similar to C, C++. You simply, but at the top, we have to import in NumPy, and we want to say import NumPy as something. You can name it NP, you can name it another name, but stick to something close to the original library name. And then you create an object, and here we have the object A. And since we had named this NP, we would use the identifier for the actual package, and then we would say array. So what we're doing is we're using the array method from the library, and in it you would initialize the actual value. So what it will do, think of it almost like the dynamic array in C, C++, where it would change the size of the array based on what you initialize. So the values that you put inside the square brace here, that indicates that those are the values that are going to go into the container. And each of them are going to be the value for each of the index, starting with index 0 as the first. You can also force it to be a certain type, right? By default, in Python, it's intuitive in that if you don't type it, it would automatically refer to how you initialize the objects inside that container. But what if I want float, or I want int, I want, a certain data type? Well, there is an option in Python, or what's called an attribute, is called dtype. And what we can do is we can use it to make sure that it's typed for a certain data. And you know that we can use 32-bit or 64-bit, but if you want to type it for integers that will be for 64-bit, that's going to give you a larger size to store your values. And so you simply would just say dtype, and you would specify the type that you want. Okay, we will see that we can also do float 32-bit and so on in the next example. So here, the first line, it shows you that you can create an array using the array method from NumPy. And then in the argument, you simply put the type of data that you want. So if you want integers, you can put int 64. If you want float, you can put float 32, but make sure that it's in the quotation marks. You can also use the second line. So once I create the object, I can convert it to a certain type by using AS type. So that's another way that you can also convert. So when you make integers into the float, if it doesn't have any decimal points, what it will do is it's going to put the period after, right, the whole number, because there's nothing else. Now, to make your data look like they would have certain values, then you can control your precision point, right, which is the decimal points after your number, by using the format feature in Python. Okay, so we will do some of this starting right now, actually. Okay, so we talked about install Numpy. Make sure that you install it on your IDE or on your computer. Okay, using pip 3, or if you're using Tawny like me, you would go into tools, manage plugins, search for the package, and then click install. And then that takes like a minute. Then what we will do is we would then go to the next exercise. So it tells you to write the Python script to create NumPy array that contains 50, 60, 70, and 80, right? Using NumPy array. So the first line of your program should be import NumPy, and you can use NP, and in my case, I just use NumPy, NUMP. And then you would give your array a name. So I just put new array is, and since I name it num here, I'm going to bring that down here, and then I'm going to use the dot array method. So here I'm going to use the array method, and then I want to initialize the value that's asked in the question. So say 50, 60, 70, 80. Now, if you want to print this, you can simply do a print, right? New array like this. And then we will touch on how to use a for loop to do that later. Okay. So just to show you. Okay. And then I'm gonna name this. Actually, I have one already. Sorry. Let me open it. Okay. So as you can see down here, we have the array printed, right? And that's really easy. So for number 2, we have an import statement. We create an object, which is an array. And we are going to use the method from Numpy to initialize the values in that container, which is an array. And then if you want to see the content, you can do a print. Okay. Any question? Very similar to C++. So at this stage, what we have is we have an actual array. Now, what if I wanted to make the values, the element values to be float? I can do a D type or I can do an AS type. So you can do it directly inside as an argument here, right? So I have, for number 3, it asked me to use the array that I created in number 2. And then I can do a D type or an AS type to convert the data type to float. And that will be 32-bit. So I did it both like what the book is shown so you can see. And so for number 3, we would start with an import statement, just like the last one. In this one, I rename my array. So I put it convert. I use array. That's just for conversion array. And I'm using the array method here. I initialize the values in the array. And then you don't have to put this, but I put this so that way it also be able to type it as float. And then I can do an AS type here. Okay. And then you can print out your array if you want to see it. So let's look at the code. Okay. So if we put a print statement here, and then we would do another one there. Okay. You will get the same by doing D type, or if you're doing AS type. Okay. So it'll give you the same output, you see? Okay, so we can use it, D type as an argument, and the other one we just use the AS type method. So if you have data that you pull, let's say from a database and it's in CSV file, right? We talked about when we did the review, how we can put the data into our program. Well, what if you take some of that data and you put it into an array and then you want to convert it, right, to the type that you can use for calculation? Then you can simply do this. Okay. Any question? Okay, so 3 is just an extension of 2. You can always add to number 2 and then either add the second part, but the question asks you to ask the AS type. So one more line. Okay. You can put the script there, or you want to screenshot it, that's fine too. Okay, so far we've been working with only one dimension array. We want to do two-dimensional array. And two-dimensional array is in the next part on page 2 and 3. So here shows you the example on how you can create two-dimensional array, right? We have one dimension, it's 0, 1, 2. The second dimension is 3, 4, 5. And notice that we have a double square bracket. So you can simply use the array method from Numpy to be able to create your array. You can print it out. And it's going to print out what's in that container that you initialized. Okay. So if we have data, so we have one list, another list, and we nest it, right? 2 lists in 1, so we have 2 dimension. So for the next question, we are going to create a 2-dimensional array. And we are going to have 100, 200, 300 in one, and the second one is going to have 40, 50, 60. Then we want to display the content. So as you can see that I have my script here, and I will run the program for you to see. So just like the other two, we would start with an import statement. And then we would create an object that's going to be our array. So in this one, I name it 2D array. And whatever I name for the import statement here, I'm going to use that here. I'm going to use the array method. And I have a double square bracket Then I have 100, 200, 300. That's what's asked. And then 40, 50, 60 for the second list. And then I can print it to see the content. So all of these are integers. They will be stored in an array called 2D array. So that would be how you would create a 2D array. Okay. And then when I run this, it would show me the content. Okay. Let me close the assistant here so you can see everything there. Any question? So in this one, we create two-dimension array, and you will see that you will have many dimensions as we work through our next few exercises. Okay. All right. 3 lines. Pretty easy. You can write your script directly in there, or if you want to screenshot it, you can. Okay, so in the next part, what we're going to do is we are going to work with shape. And the way that we utilize shape is to use the axis for each of our dimension. Okay. So in the next one, if you refer to your notes, page 3, it talks about the shape method attribute. So when we created the two-dimension array in the last exercise, what we're using is we can initialize the value for each of the dimension or each of the array that we nest in the container. Numpy uses the term called axis. And what it is think of it like how you would do X and Y, right? For rows and columns. So we would say, okay, if in a way it looks like how we would put it into certain number of rows and certain number of columns. So what we can have is we can have, in this case, we are going to do 2 rows and 3 columns for our array, which is 2-dimension. So what you can do is you can use the shape method or the attribute, and then you would simply specify how you want to shape it, how many rows and how many columns. So if I have a 4x4, then I would do 4, 4. If I have, you know, a 2x8, I would do 2, 8. And we can utilize the array and we can reshape it also using the reshape method. So once you have it in a certain row and column, you can still change it by using another method called reshape. Okay. So here what they're saying is that you can make your array in as that would contain 16 elements in many shapes. You can have it 2 by 8 or 4 by 4 or 2 by 2 by 4. Because if you simply take 2 times 8, you get 16, 4 times 4, you get 16, 2 times 2 times 4, you get 16. So in this one, it's 3-dimension. And it would be 2 and then 2 on one and then 2 on another and then 4. So you have one axis that has 2, another axis that have 2, and then the third axis you would have 4. And that will be like equivalent to what we see in mathematics XYZ. Okay. So we can either, first we can shape it or we can take an array and then we can reshape it. Now in the next part, it shows you how that can be done. So first here, I have 1-dimension array, see 0 through 15. And what I can do is I can reshape it. I can reshape it to a 4 by 4 because it has 16 elements. I can put it into 4 rows and columns. Or if I want, I can make it by 2 by 8. So that will be 2 rows and 8 columns. So if you use the reshape method, you simply specify how you want to shape it, how many rows and columns there. And when it outputs it, it organizes, it cuts your array and then it puts it into the subarray subsequently, starting with the first element. And because array is designed to be contiguous, right? Storage, meaning that the first element is next, the element index 0, next to element index 1, and so forth. So the way that they design the method is that it's going to chunk the container into equal parts, whatever you tell it to be, the rows in a column, and that's how it's going to organize it. Okay. So at this point, we would know how to use shape and reshape. So for the next exercise, we are going to use the shape attribute. Now, if you just use the shape attribute, it would give you the axis. But if you use the shape attribute with the arguments, it's going to execute, it's going to take your array and cut it. So number 5 asks you to use the array created in number 4. And you are going to use the shape attribute to display the axis of the array, because we already initialized it as 2-dimension. And we want to show the script and our output. Okay, so here is number 5. So I simply want to print the shape of my array, right? I use the same one as number 4. So I add a line called print to the array. And it's going to tell me 2 by 3. So 2 rows and 3 columns. Think of it like X, Y as a pair.
Question.
Yes.
So what are the potential axes for the 2 by 3?
I'm sorry.
The axis.
Yeah,
Is
axis.
there's Is there like, you can have axis equals 0, axis equals 1, and axis equals 2, or?
Yes. So what you have is, this is going to be, right, each of these are going to be in the column here, right? So from X to Y, your first index is going to be 0 to 0. So it's going to map that point there for 100. So think of it like how you graph in algebra, right? So it would place that 100 there, and you will see on the later one, we're going to move it horizontally, where we don't move things vertically if we don't change the column. If we change the row, how that would look like when we reshape it. Okay. So potentially, whatever value that you initialize at the element, at that point, it's going to be, so I'm at 0, 0, which is the point where that would be for the first element. That for the 100, that will be the 100 value. That's how it's going to map that value to the index of the row and the column. Now, 2, 3 doesn't mean that it's at 2, 3 index. 2, 3 just means that it's the dimension of your table. Think of axis as a table, okay? Because the way that they describe it is just, it represents row and column. So if you say 2 by 3, that's just a table that is 2 row by 3 columns. If it's 2 by 8, that will be 2 rows, 8 columns. And the first one is always gonna we're still gonna refer to the index that will be index 0 by 0. It's gonna be 0 at 0. First list, first index. Okay, other questions? Okay, so you saw a little bit of reshape example, but what we're gonna do is we are going to use random, okay? So in the chapter, after it goes over how to use reshape, this one you initialize, and then you can also use something like with 0 method, with empty methods, and with ones method. So what if you wanted to make a table, right, that would be 3 by 3 with all ones? Then you can also use ones method. What if you want to make a table that has all zeros? You can have the zeros method. Now, what if we want to automate the process and fill in the numbers with random numbers? We can use random from Numpy, and we can simply import in our random. That's what we've seen in the past. It also have other methods such as 0 like, empty like, and ones like, and we will do these so you can see the difference. Okay. So for the next question, we are going to use random. We are going to create one dimension array first, and we are going to actually, no, not this one, not random. We are going to initialize 1 through 20 for our array. And you can loop it to create it, but I simply initialize this. We are going to use shape and reshape. Okay. So let's open that up. That's number 6. So here is my array. I start with an import statement like the other ones. Then I have an object called array1. And I'm going to use the array method to create the array, and I initialize from 1 through 20. Then I wanted to show the shape of it. Then I have a reshape statement and I wanted to print that so I can see. I wanted to reshape it and then print. So it would take this and restructure it to a table that will be 4 by 5, which is what's asked in the question. Now, if I wanted to show the axis after it reshaped, I simply, you can do a print with the reshape, like what you've seen here. But what I did was I also put it into a variable, and then I show the variable. Okay. Let me pull up my thing so you can see. So the first shape, it tells me that it's 20 elements, it's 1 dimension, right? That's the first print statement there. And then I took that, and what I did was I put it into a 4 by 5. So here is the first row, the second row, the third row, and the fourth row. So it's 4 row and 5 columns. So each row have 5 numbers. So it cuts it evenly. Then, so after I have done that, that's the second print right here. After it reshape it, so it gives me the content of my array after it reshaped. Then for the second print, I wanted to show the shape of the updated table or my array. So once I reshape it, it takes a new shape, and I wanted to print the content, then I print out the shape. We know it's 4 by 5, but it's just, I wanted to show you how you can also print. Any question?
Yes.
So,
What would be like axis 0 and axis 1 or axis 2 in this output?
axis 0. So if you have only, okay, so if you have no column, then you would have 0. Like if you only have rows. So in the first one, you have 2, 2,0. That's what it is. So that's like just one container, one row, right? And then if you have like, let's say 1 by 2, and you can play with the shape. If you have 1 by 2, so that will be two rows of 10. I mean, I'm sorry, 1 row, and then each column has 10. So it'll be like this. Yeah, more vertical. I don't know if you can visualize it. So it's going to take the first 10 and then put it into one column, and then the second one. Now, in the case where you force it, and if it's not able to make it, it's going to throw an error. And the book does say that. And I tried some of it where when I manipulate it, and if it's out of bound, it's going to tell you it's out of bound. Okay. So you don't have to do 4 by 5. So let's say that if I reshape the second time, let's say that if I do like a 2 by 1 like this, right? 2 rows and 1 column. And then let's run it. Okay. See how it didn't like that because it can't create it, right? Because if you take 20 and then you're trying to make two rows, but with one column. So if I do a 2 by 2, it's gonna do it. New array, cannot reshapes. Yeah, so the size of 20, it doesn't want to do a 2 by 2. Okay, because if you do a 2, that's gonna make it 2 row, right? And then 2 column, it can't divide it equally in that. What if we try like 10 by 2? Like this. There you go. And then if I wanted to do print array new shape, and then I can just do a print array underscore new here. There is the 10 by 2.
So if I wanted to print just access 0, which numbers would those be?
Access 0. So that will be
In your
just,
10 by 2 example.
Yeah. So here, right, your access 0 is gonna actually be free because you can't. Okay, so if you have column 0, are you referring to column 0? So then that will be just it won't be any of these, because then you would start with the 1 that will be at row 1, column 1. I'm
So
sorry. The index wise is going to be 0, 0. So that would be a 1. But if you like just going back, so if you have an axis 0, that will be the first axis. And if it's not moving any vertically, it'll be just the first row. You get what I'm saying? So think of it like X and Y, right? At the original point, which is 0, 0, it will be there. But when you move into the first index, if you move to the first index, it will be the first list, the first index. So if you're looking at the first list, the first index, both of those things are going to have to be 0, 1. I'm sorry, 0, 0. And then on the second list, if we cut it into a second list, that will be 0, 1. Okay, that will be the first element of the second list. So if you're saying an axis 0, then are you referring to the first axis? Because it actually has 2, right? You have an X and a Y. The first axis is going to be 0, then that means 0 column. If you're referring to a Y axis, that will be 0 Y, 0 column, 0 row, I'm sorry, 0 row. So if you're saying that if we choose a certain element and when we cut it, later on I'll show you how you can do index. But if you're looking at this list, right? If I want to choose 1, what would that be? My index is going to be 0. My first list is going to be 0. If I choose 3, then it's going to be what? This is the second list now. So this is going to be, the index is going to be 0. The list is going to be 1 because it's the second list. If I choose 5, the index of the element is 0 and the list is going to be 2. Okay, and so on. So all of these right here, what you would see is, I'm going to type it out. So when you're referring to this, your index is going to be where the location of that element in that sublist, and then your list value is going to be subsequent.
You know what? I was referring to an example in the book where they just print out like where axis equals 0. and then I'll print out the other list where the axis equals 1. So that's what I was sure about. Not the index, just the axis. I don't know if you have that example in the notes.
Let me see. I thought I grabbed everything that was referring to the axis. Right here, is that what you're saying for the shape? Where when it's fixed is 0 right here? Yeah, I think that this is when they do extract. Yeah, so when you do a 0, 0 like this, right? So basically it's, think of it X, Y, you're not moving. So it's the first element, first list. And then you're doing the first element, or the second element, first list, and so on. So what it's doing is it's moving horizontally, not vertically. So if you think about like how it's on the table, it's just moving across. It's not moving up and down. Yeah, and this is what's used for extracting instead of using the index. You can, and it's still referring to the index. So it says here that if you think about how the second one is fixed at 0, like Y axis, if you're not moving up and down, if you're moving just across, that's how you're able to access it, is using the pair like this. Like 2-dimension graph. Okay. Yeah, like XY coordinates. I didn't put the picture for the XY coordinates, but if you can visualize that in the XY coordinates, that might also help you. I look at it from a table standpoint because it's a little easier to visualize, but okay, we'll come to this. Other question? Okay, so we can do a 4x5 for that one. Okay. And then now if like I said, if you put in the parameter and it's not able to cut it evenly, it's going to throw you an error. It's going to say that your axis is out of bound. And then so you just think about the number of elements and how you wanted to cut it into the subarray or nest those arrays. Okay. So we saw number 6, and then we're going to do number 7. So for this one, what we want to do is we want to do a 4x4, a 4x5, and another 4x4. For the first one, we are going to put everything to zeros. We're going to use the zeros method. The second one, we are going to use the empty. And then the third one, we're going to use the ones. And then the last one, D, we're going to make it random. Okay. So pretty easy. Let's open number 7. So to start that program, you simply have an import statement like the other one, and then you want to import random. You can also use random from Numpy, but I always want to import random in case I need to. So because in the past we've used random before, right? So I want to import random. Then I want to print out elements at zeros using zeros. So here I put the string so I can distinguish which one, and it's going to be 4x4. So I simply use the 0 method, and then I wanted to specify my axis. So it's going to create an array and it's going to fill all zeros. And then I'm going to use an empty method. That's going to be 4x5. And then all ones 4x4. And I wanted to do a float on this one. So you can see like 1 point something, right? And then lastly, I'm going to do a random. Okay, so let's pull up so we can see starting with all zeros. So as you can see with all zeros, right? It made 4 by 4. So I have 4 subarray of 4 elements each. And it's just initialize them at 0 for each of the element. For the empty method, what it would do here is it's going to cut the location for me. It's going to be 4 by 5, but these are just referring to location. They're not really values. Think of it like address or the memory locations. So I have a 4 by 5, and those are allocated for something that I can initialize later. Because you ask it to print, it's going to give you the specified location, and they are contiguous. Then we are going to do the once. So when you do the once method and you force it to be a float, it's going to give me 1 point. Nothing is noted as a float yet, but because we initialize at 1, it would just be 1 point. So that's also a 4 by 4. So 4 lists of 4. And then lastly, I have the random where I create a 4 by 4. That's going to be a random. And for random, I would have these values. So basically, it's just going to put whatever values in there, sometime under 1, sometime above. It's pseudo random, we know that, right? So there you have it. And in number 7, we're able to use some of the methods that were created from the library. And this is to show you how you can quickly create container and store things into that container using those methods. Any question? Okay, so for 7, you can also look at the example in the notes and the text. There are quite a few examples that they include there. Okay. And similar to what you've seen with the zeros, the ones, and the empty, we can also use zero like, ones like, and empty like. Okay. Um, So we can quickly initialize some of the value using these methods. So number 8, it's gonna ask you is we are gonna use 0 lights, 1 light, and empty lights. These are gonna put in again your addresses. So there should be, I should put spaces there. So what we're gonna do is we're gonna start with an array 10, 20, 30, 40. And then we are going to use this method to convert the values. Right, so you can update them by using those the methods as well. And then you can also use them at when you use an empty, it's just going to create the space. So here we go for 8. So I have an array 2, and I'm using Numpy. So I import Numpy and I use array method to initialize my values. I have 5 elements, 10, 20, 30, 40, 50. Then I'm going to print. So for the first one, I'm going to use 0 like, and then second is going to be 1's like, and the third is going to be empty like. Okay. So when you did the zeros, right, it's going to put the 0 as integer in and replace all of my elements. So you can zero out all those elements that way. We will put in the 1's like, okay, and then so we would be able to put the 1's in. And empty like here, unlike the other ones that you've seen where it actually put in the addresses, it just round off these values to an integer value. So it looks like it's a whole one, but it's actually location. It just round off these values for you, the location value. So it just put the 1's there. So basically it's slotted 1 for each of the element there. Okay. So just want to experiment with some of these methods and see how you can use them down the line. Okay, any question? That was for number 8. So we would be able to also access array element using a for loop, very much like what we've seen in list, right? You would use the index. You can also use the for loop, which is shown here. And that will just iterate through and pull the values, from the first to the end. And then you can also specify, right, which index you want to access. So when we're looking at this array, it has 3 subarray, right? It's 3 dimensions. So we have 3 by 3. Then you have the first element is going to be the first element list first. So it's going to be 0, 0. Then if you move to the next one, number 3, that's going to be the first index and the second array. So that will be 0, 1. And then if you move to the 6, that will be the first index. And that's going to be the third list, so 0, 2. So here it says to get the second element in the first row, which is this one, we can use 0, 1 because 0 is the row and 1 is the column. Okay. Important observation is that A0 notation is actually shorthand for 0, 1. We're actually indexing, we're using tuple. So when you're using array for Numpy, think of it like XY coordinate or a table, right? Row and column, that's gonna help you. Okay. All right. So the example that's provided here, what it's doing, it's using this index. And you can also use the index to slice, just like how you slice string in the CIS-30E, you would use the colon. You can do it from certain point to a certain point. You can slice it. All right. Any question? So we are going to do a 3 by 3 for number 9 array. And first we are going to create an array, and you can initialize however you want. You want to use a for loop to access the content of the array. Then for B, you are going to use the index to access the third subarray, which is the third row, and display its content. Then you're going to slice the first of the 3 by 3 array into the 2 dimension. So you wanted to cut out one of the dimension, right? Remove one of the axes. So there's several ways that you can do that, okay? And then for the last one, you simply just create another array that contains 6 elements. Then you're going to slice it down to 3 elements using index value and display the content. All right. Any question with 9? So I have hold on one second. Let me fix something real quick. Give me a second. Okay. Let me share now. Let's pull this down. Ah, maybe right here is good. Okay. So here's 9. I have an import statement. I initialize the first array. I call it array 3. And then you can give it any value you want. So I just go with 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I'm going to use a for loop. So I just put print, and then for the for loop, you can just enclose that in the square brace. So you would have I, you can use any variable. I just put I for I in array 3. And I wanted to print it. So what it's going to do is going to loop through. It's going to print that out. And then I only wanted to display this one. Okay. Which is going to be my my third array, which is the column. So I wanted to do 0, 2. Then I wanted to use the index. So notice that I'm using the parentheses here. Now I'm just going to use straight index for the next one so you can see the difference. That will be 0, 2. And then the next line, I'm going to slice it. Okay. So I'm going to cut these into a 2 by 2. You can do the axis, but I wanted to use the index. And then I'm going to then slice the array 4, which is the next one, into 3 elements by doing 0 to 3. And then if I want to update the value, I can update a certain value into the index. That's just extra there. Okay. So let's start from the top. So when you use a for loop, unlike the print, it actually take each of them and then it would put it into a tuple here, and then it would notify you that it's an array. Okay. It's slightly different than when we do just a print and then an array name. That would just be just the value, the elements inside the array. Okay. So when you're looking at the axis, when you're using what the book is suggested, when you use it like this, right? The third subarray using the axis, then you would have 3. And then if you just use the index, it will be also the same, exactly the same. Then when you slice it, we can slice it down to 2 elements, a 2 by 2. Take it down to 2 dimension. So that's going to give you a 1 and a 2 and a 4 and a 5. So it's going to drop off the 3 and the 6 because we told it to go 0, 2 and 0, 2 on the second. So it's going to go 0, 2. It's going to stop right here and then 0, 2. That's this line. So I cut it down to that one. And then I'm going to take the second array, which is array 4, and then I'm going to slice down to only 3 elements, the first 3. Because it originally had 6. So when you do that, you just specify the index from 0 to 3. And then if I want to update the value with another number, but that will be 10. So I want to replace the 100 with the 10. I simply use the index. And if I change this to 1, right, oh, just like, let's say I wanted to make this 20. I can also do that and it will update it. See? So just reassign the value. That's what you're doing there using index. So let me put it back so you can see how it was. Okay, any question? Okay. So the example in the book is helpful. Also, I include that in the notes. So you can refer to the notes for some of the information as well. And I will try to get the video up tonight, if not tomorrow morning. Okay. So here it also shows you how you can slice it, can update it. Okay, any question with 9? Then we are going to look at 10. Oh, I'm sorry, we did E already. 10. So write a Python script that fulfills the following tasks. Create an array that has a shape 3, 4, 6. And it's going to contain randomized values. And then we're going to create another array that has a shape 3, 6 that contains randomized values as well. Then we are going to use a broadcast feature to operate the multiplication of both arrays using index, using it while adding the access to the second array from step B. So before we do this, we need to go to the section where it talks about how to broadcast. So if you want to look at extractions, you can also look at the extractions there. We're going to touch back on this when we do some of the later exercises, okay? And basically, this is used what's called a fancy index. And it's just a way of indexing. Some of you seen this in string object when we did the slicing for the string and extracting some of the values from the string. So similar to that, where you can just put the colon and it's able to pull some of the values for you. Now, you know, the way that they did this is when you extract, make sure that you put it into another container, like a variable for another array. Otherwise, it's not going to be able to pull the value. So when you extract, technically, it's just in what it does is it's really referencing the location where you initialize the value, and then it's going to be able to go and pull it. So when you pull it, you need to store it into another container in order to access it. Otherwise, you're gonna run into a hard time. So I was playing with this a little bit. And then the way that they had it, as you can see, is that they would put it into a variable and then be able to use it to display the result. So it's recommended that you do that. If you pull a number of the elements, of course, you need to put it into another array, right? Like how they create that here, they use the array method to initialize and then to put it in there. But the way that you look at it is just you can use the index value. Now, it says that you can also use a normal list for the index arrays, but not tuple, because tuple cannot be modified. The content of tuple is static. So if you want to change the value as you extract and add it in there, you cannot use the tuple. Okay. So you should make it into like a list or an array. So now the way that Numpy uses this is the same as this. This we've seen in lists already, but you can put the parentheses. You saw that in our last exercise. Okay. And then you can also use bool type. So importantly, we see this here. So what they did was they did a time it test, right? And then they had it, they look at how it's going to use the axis is 0. So this is Michelle's question earlier. She said, well, what exactly is this right here where it would be the axis is 0? So that means that it's so there are 2 columns and 100 rows in this right here. So if we're moving through the rows only without changing the column, so what it's doing is it's going to loop at every single first element first, and that's why they state the axis is 0. So that place, think of it like that, place the marker at the first element every single time, so that way it will position the loop for the first element of each of the subarray. And that's why they're doing that. The axis is 0 there. Okay. And then because if you look at the index, if you do 0, 1, right, that's just the 1 just indicate the column or the subarray that you're accessing. The 0 is really the index of the element. So when you state that, what that does is it's going to position the beginning of the loop at the first element of each of the subarray. And as it position that, so think of it, it's just going to move horizontally and not vertically in the graph. And so what we can see is that we can see how the time, so the best time for this is 962 nanosecond per loop, right? Using this. But if you use it with the index container, it is 9.03 microsecond per loop. So there's some difference in time, how it operates. So that explains also on, really how you want your position or your index to be accessed. If you write it this way, it is different in time on how it executes if you write it this way. Okay, so keep in mind that, they are slightly different there. To humans, not so much, but, system-wise, you do see some difference in time change. Okay, and then they also did other tests here to give you the results so you can see. All right, so broadcast allows you to use multiple array and apply operations like mathematical operations, do comparisons. So, use your general operators for broadcasting. And it basically is going to go across the element of the array. And then if the second array is not the same length, it's going to try to fill it. So that way it would be able to compare. So the way that it shows here is that you have the first array 1, 2, 3, and then the second array is just 2 and 2. So when you do A times B, it's going to take this, multiply it by this, right? And then this, multiply it by, so it's going to do the combinatorics. So 2 and 2, so 2 and 1, 2 and 2, 2 and 3, and then it's going to move to the second 2 and 1, 2 and 2, 2 and 3. And then the last one, 2 and 1, 2 and 2, 2 and 3. So basically it does the counting, the combinatorics, where you would have 2, 4, 6, 2, 4, 6, 2, 4, 6 is going to match up. Now, when you only have one element in the second array, that's easy. It's going to take this and it's going to multiply it across. 2 times 1 is 2. 2 times 2 is 4. And 2 times 3 is 6. Okay. So the way that it operates is going to be that it starts with the dimension and it works its way left. So usually it's going to build on the last because it's last one first out, last in first out. So then if you only have one, it's going to multiply across the others if they're equal, right? So there are two ways that you can be compatible. If they're exactly the same size, right? For one of them is 1. What it will do is it will stretch. So it's going to make this into something like this, 2.0, 2.0, and 2.0, like that. So basically it's going to stretch and it's going to look like this. Okay. And if you want more example, you can also go to the broadcast information, which is their documentation. Another way that we can visualize this is like this, using what's called the scalar. So we have A1, A2, A3, A4, A5, A6, and the same thing with B. So if B only have 2 elements, it's going to stretch it. It's going to copy the exact ones, right, and extend it to the rest so that way it will be equal in size of A. Then what it will do is then it's gonna give you the combinatorics. So A1B1, A1B2, A1B3, and then it's gonna move over to the next one, A2B1, and so on until it's finished. So you would end up with the combinations in the operations at the end. Okay. So if this is multiply, and if we're doing, use other operator, it does the same thing. And so what we ended up with is like this, a 3 by 3. Okay. So again, it's going to try to stretch and match up with the other array. And then it's going to cross distribute basically. So that way you would have a combination. So let's try the next one so you can see. Number 10. We're going to make an array that has the shape 3, 4, 6, and another one that has 3, 6. And they are both randomized, and we're going to use the broadcast feature. We're going to multiply them while adding the axis to the second array. Okay. So here we go. Number 10. So with this, we are using also a feature called fancy indexing. You saw some of this when they talk about the extraction of values. So I have the first array is array 5, and the dimension that's asked is 3, 4, 6. I'm randomizing, so I'm going to fill in the values there. I have another array called array 6. That's for number B, 10B, and I'm going to randomize, and it's 3 by 6. Then I want to multiply these two together. And what I'm going to do is I'm going to add the new axis. Okay. Because notice that it's 3, 6. So we want to add the 4 in to match the second one, the first one. So I wanted to basically stretch 6 to make it like 5, and then multiply it with array 5. Okay. And I wanted to print every time so you can see the difference. All right. Hold on, let me put in the string so you can see here. So array 6, and then we have result. So here's my array 5. Right? And then I have the array 6. But which is a lot less, of course, because it doesn't have the 4. Then I wanted to print the result where I multiply 5 by array 5 by array 6 while adding a new axis, which is 4. Okay. And the first one is 3-dimension. The second one was 2-dimension. We wanted to make it 3-dimension and multiply it. And then we wanted to output that and store it in array 7. You can simply print it like this, right? I just wanted to clean it up so that way I have the result here and I can use it for something else. Any question? And when we randomize these, you can see that most of them are just 0 point something, sometime a little higher. But it depends on how the system seeds it, right? So 10 is about a few lines. So you can see. Okay, I'll leave it there for like a minute. And do you have any questions? So you will get questions on our upcoming quiz, which is probably going to be a week or so from now, on the arrays and also how to slice, how to use the index, axis, and so on. And then you will have an element of your project that's going to require you to use array with Numpy. So make sure that we know how to use this in practice, right? I only have like about a couple hours with you, so we just simply do some of that. But if you have the textbook, you can do some of the example. You can use the documentation and do the example in the documentation. That's helpful. Okay. All right, let's move to the next part. So toward the end, it's going to talk about operations. So you can use mathematic operations with array, just like how you would be able to use it with variable. Okay. And looking at Python and other languages, you can see that it's when you use a library like this with Python, it's beautiful in that there's not a lot of like extra stuff that you have to do in order to access the array and initialize it as a constant and so on, right? So you can compare using the operator, the comparison operator, which we'll be doing. You can, and it doesn't have to be value, you can also look at bool values. So you can compare. So let's say that I have test results from, I don't know, medications or whatever the research lab. And I wanted to measure and make sure that the result, right? The result will be over a certain decimal or a percentage. I can compare a whole group of data that way, just using the comparison operator and be able to do that. Then I will be able to display some values. I can multiply, I can do additions, I can do subtractions with my array. Okay. And then ultimately we can sum. So thinking back about, your first few projects that you've done in CIS-30E or another class, you would have to do like, a running sum and so on. Well, now that we can actually do a sum that's quicker by use and for multidimensional for a larger scale array compared to what we've used one dimension before. We just add everything up, calculate tax or something. And it seems very tedious, but now you would know how by doing the exercises that we're going to be addressing next. Okay, so you can use the sum method. Okay, and when you have no argument, basically it's just going to flatten the array, which is it's going to go through and just going to add across. Where if you put in the argument on which axis you're summing, right? You can specify the axis one that you're summing, then it's going to give you the output for that. Okay. All right. So in the next question, number 11, it asks you to create an array that has a shape 2 by 5, and it's going to contain randomized values. Then we're going to use a comparison operator, and we're going to compare the element values to 0.7. You can use less than or greater than, that's up to you. Then we want to display the values that will be true based on the comparison. Then we're gonna sum, and you can choose, you can sum up the value for the first and the last axis. Okay, and display the sum. Okay. All right, so let's look at it. Number 11. So I create an array and it's called array A, and it contains randomized value. The shape of it is 2 by 5. And I wanted to print it to see the content. And then I'm going to do the comparison. I wanted to do greater than, so I wanted to see the elements that will be greater than 0.7, 0.7, and then I wanted to print it. Okay, you can do a print there, but I wanted to show you as a separate line. So here's that. Then I wanted to sum up the first axis and the next one. So, okay. So when we look at this, what we have is, oh, so it's still showing. My array A is this right here. Okay. The only value that's greater than 0.7 is 1. It's a 0.983, etc. This one right here. And this is good for, like, you know, looking for specific data. And then if I wanted to add up the axis 0, it will be this. And then if I wanted to add up the axis 1, it will be this. Okay, so you can use some method, you can use mathematical operations, you can use comparison operator, arithmetic operators. Now, let's say if I change this to less than, see what it does. Oops. And we can do a less than and a less than here, right? And then let's run it so you can see the outcome. So when we're looking at less than, we have more values, right? Even though I randomize it the second time, pretty close to the first, it still has a 0.92 at that location there. I do have another one that's greater than 0.7 in the second round, but I do have a group of values that will be less than 0.0, 0.7. And then when I sum it up, and there you see that you can use operators. And you can refer to the notes starting with 14, I believe, going forward. And that concludes my part on the illustration for exercise. I just want to wrap up talking about maybe just a little bit on Panda, and then we'll touch on Panda on Wednesday. Okay. So another thing that your book brought up was you can use number expression, which is numexpr. And this is a package that's written by David Cook. It also allows you to use array quickly. It's a way to optimize the usage of processor and how you store data into the storage of the processor. And when we look back in how Numpy is used, right? So a way that you can use it, it would be like this. Okay, so this is a package that you can import. Okay. And an example, I pulled this example from their guide, is that let's say that you are using Numpy, you can also use num expression, numxpr with it. Okay, like your A, your B, your C, and then you want to operate some mathematical operations. So it's gonna be seamless. Now, this uses the expressions and treat it like a vector-based virtual machine. So it's not capitalizing on your cache in your processor. So it's able to um, not take up too much storage, and it's going to help you optimize your program. So that's another way that you can use your packages. And if you want, you can check out the guide. They do have great tutorials and an example for you to also look at and practice. Okay. Then the next part is going to be on Panda. And so Panda relies on Numpy. It's a way that we can establish data structures. And the way that we create data structure for Panda is going to be called series, data frame, and panel. Okay. And the best reference that you can actually look at is Panda's user guide. Okay. But I did pull, as you saw earlier when I first opened my program, I did pull some of their example and I put it here. Okay, how you can create series, how you can make a data frame. So series, you know, that's the same name that we would use in mathematics, that we would have a group of values where there would be some kind of progression. And, you know, it has some kind of sequence in it. And so we can build a series. Then if you want to make a data frame such as your dates, right? Like the dates that's going to be contained in a week, 6 days. Okay. And then you can also have a data frame that contain all random values. This is kind of similar to what you've seen with the shape from array. But and then we can organize it into column, and then you can print the data frame. You can also incorporate dictionary into your data frame. So as your data gets larger, right, you would require more elements to your data. So then you can have, you know, things like timestamp. You can have series that's incorporated. So you would have a larger container that holds smaller containers within. And that's what it's showing you. Okay. And you're going to start seeing why Python become a preference when we're dealing with data, because the flexibility and how it would grow with the data and the type of library that we can incorporate. Okay. And you can view the data by using some of the method that's incorporated in that library. Like top down, you would say head, tail on the bottom, and then you can specify the role of it. You can also look at the index column or add it. You can also show a certain columns. Okay, so let me run this so you can see. Okay. And so the first part we talked about, this is your series, right? And so very similar to what you've seen in array. Then we will also do a date range, right? Remember the calendar and things that you have to incorporate. So here, what we can do is we can tell it, we can use the date range method, and we can say the start of it and how it's going to be the period. So I'm going to start with January 1st, and it's going to go into the 6th. So you simply pass the argument here. The parameter, we would say period is 6. and this is the start date. So it's going to span that out for you. You can go further. You can do 36 or 30 days or whatever, right? And just make sure that your type is going to be suitable for the type of data that you're using. And then we created a random data frame, which contains signed and unsigned value, positive and negative number. And we organize it by column A, B, C, D. Okay, there. Then we incorporate a dictionary with another frame. And then now how you view the dictionary is you are going to call, right, the appropriate method. And whatever that's executed, it's going to give that to you. So if you want it only top, right, you can say, you know, data frame head, and it's going to give you top down. If you want tail, then you can just call tail. You don't want to do multiple like me. I wanted to show you how that's done. So I added the code there for you. Okay. But you want to call the method here on how you want it to be displayed or how the data is used. Okay. And this example you can find in the documentation. You can also check out additional example because it goes on a lot further. But that kind of gives you the basic on how we're going to look at frames and data and such for Wednesday. All right. Any question? I'm going to stop recording.